This is chapter 5, problem number 16. The lucky number for this problem is 2, number 2, this number here. All right, let's look at this problem. This is a pulley. What is the property of a pulley? If you have a pulley, that means the tension on both sides of the cable will be the same. For example, if you have 5 Newton pulling on this side, that means the other side will feel 5 Newton pulling it up. All right, let's look at this problem. That means whatever this force is, okay, so let's look at it. There's a pivot over here. And on the other side, at the end over here, there's an 80-pound object hanging on it, and it's balanced. Because this is a pulley, I'm going to say the force is going to be in this direction. And by the way, for any cable or string, you can only pull it. You can only stretch it this way. You cannot compress a cable, okay, because it will collapse. On the other hand, if you have a beam, so you can put the force, compression, or tension. Either way will work for a beam. All right, so let's look at this. I'm going to call this my pivot over here. So it's freely to move in these directions, but now it's at equilibrium. That means the moment or the torque is equal to 0, the overall torque. All right, how do we do this now? Okay, let's focus on over here. If this is a force, this way will also be the force, F. The magnitude would be the same because this is a pulley and it's connected by the cable. If this is a force, so we have both the X component and the Y component. If this is 1, so let's isolate it. If this is 1, 2, that means over here should be 1 square plus 2 square. So that would be square root of 5. Okay. So if this F is in the hypotenuse direction, that means the X component, F in the X component should be equal to, well, it's negative because pulling in that direction. So it will be equal to negative 1 divided by square root of 5 times the force. Okay, what about the force in the Y direction? That would be equal to 2 divided by square root of 5 times force. All right, remember what our magical formula is for moment in 2 dimensions? So moment or torque should be equal to X times Fy minus Y, position Y times the force in the X direction. Okay, you have seen this many times already. All right, so let's plug in all the numbers over here. All right, so this is my pivot. So the first force will be over here, and the force is F. Okay, so X is equal to 5. I just want to plug into here. X is equal to 5 times Fy, positive F. Okay, so F in that direction. All right, minus Y. Y is 0. Okay, so this part is gone. Okay, so I'm done with this force. Let's look at this one. And by the way, the torque will be a positive number. Okay, because this pulling it up is going to make it go counterclockwise. That's why it's a positive number. The force over here is also going to make it go counterclockwise. All right, so let's look at the one done over here. So plus X, X is 5 plus 5, so that is 10, times F in the Y direction, which is this number over here. So times 2, let's square root of 5. All right, so, and then minus Y, that is equal to 0, times Fx, okay? And again, this force also making it go counterclockwise. That's why it's positive. We know this force is going to make it go clockwise, so it must be negative. All right, so how do we know it's negative? By looking at the formula, x is equal to 13. So you plus 13 times y is in the negative direction, negative 80 pounds. All right, so the overall moment should be equal to 0 because it's at equilibrium. Okay, so let's see how I can solve it. So this one, all right, let me put it this way. So this one is 5F. I used my calculator. So this part, if you use the calculator, it will be equal to plus 8.94 times F. And over here will be, this one I'm going to move it to the other side because it's negative. So move to the other side will be positive, 1040. All right, so I can combine these two. It will be 13.94 F, that is equal to and 40, and the force will be equal to 74.6 pounds. Okay, so the lucky number for this problem is 2.